total internal reflection of light, remember. And then we have also discussed the application of it. Say for example, mirage, what exactly happens. The two foremost conditions which are necessary for total internal reflection of light. The first condition is the light ray should travel from denser medium to rarer medium. And second important condition for total internal reflection to occur is light should hit an angle greater than critical angle. It means the angle of incidence should be greater than critical angle. And we also know what a critical angle is. So if we want to define critical angle is an angle of incidence for which the angle of refraction would be 90 degrees and the refracted ray would graze the interface. Interface is a demarcating boundary between the two mediums. So it's a boundary which separates the two mediums. So we have seen how total internal reflection of light as a phenomena being used for optical fiber communications. And we have also seen how this total internal reflection of light works its miracles out in nature so far as mirage is concerned. All right, now there are certain applications which we can always talk about, so far as total internal reflection of light is concerned. Just give me a moment where we would discuss another application in terms of prism binoculars. Now, when I talk about prism binoculars, firstly we should understand what a prism would look like. So this is a photo of a triangular prism, you can see. So if I take the cross section or the principal section of the prism and I look from this side, it would appear to be a triangle basically. So for refraction through prism, we make a use of this principal cross section, which is a triangle. This angle, you can see, you can call it as a refracting angle, and the edge, if you observe it in a three-dimensional view, this edge is called as the refracting edge. Now this triangular prism is being used in prism binoculars, and for this prism binoculars, what they do basically, they use the phenomena of total internal reflection of light to bend the light rays. Now it all depends upon us how we want the light rays to be bent, whether by 90 degrees or by 80 degrees. The ultimate thing which you need to understand over here is the concept which is being used to bend the light is total internal reflection of light, which we have seen earlier. Now let's try to analyze this diagram, friends. First of all, say for example, if I want, suppose this is an object, A, B is the object, and these are the rays coming from A, B as an object basically. Now these rays, if you see this particular edge or this surface, it's normal. The ray won't get refracted. Directly it will enter over here and it would reach the inclined edge. Now if I'm talking about inclined edge, it's a right angle triangle prism basically. So this angle has to be 45 degrees. This angle is 90 degrees. This angle is again 45 degrees. You all know the combination. Say for example, this is the point where the light ray hits the inclined surface. I draw a normal over there. You can see a normal being drawn, friends. Now if the normal is drawn in this manner, then obviously you can see the angle of incidence over here becomes 45 degrees as per geometry. Now angle of incidence is 45 degrees. For a glass air pair, the critical angle is 41 degrees. So if the angle of incidence, if I say, has become 45 degrees over here, I can straight away say that the angle of incidence is greater than the critical angle for a glass air pair. Now if the angle of incidence is greater than critical angle, one condition is satisfied. Second condition, you can see the ray is moving from denser medium to the rarer medium, because glass is denser medium, air is comparatively rarer. So the two conditions for total internal reflection of light are satisfied, friends. And therefore, if you talk about this particular point, the ray, instead of getting refracted outwards, the ray will get totally internally reflected inwards or inside. So whatever happens for the ray coming from B, same thing would happen for ray coming from A. So in a way, what has happened, the rays which were supposed to pass like this have got turned through 90 degrees in this manner. So we have used the concept of total internal reflection of light to change the path of the ray of light by 90 degrees. Now, if I want to change that path by say 180 degrees, friends, then I will just place this type of prism in this manner. The second diagram you can see. Now what is happening over here in the second diagram, you can see the rays coming from A and B. Because this is vertical over here, it won't get refracted. It falls on the inclined face, gets totally internally reflected. The ray coming from A also gets totally internally reflected. You know the reason why. Just now we have discussed the two conditions are being satisfied over here. The same case is applicable here also. But then once it gets turned by 90 degrees, again if you observe, the same rays would fall on the inclined face. So whatever happened at the top, the same thing is going to happen at the bottom. That means the total internal reflection is going to take place. And you can see the rays which were turned by 90 degrees further get turned by 90 degrees. So in totality, if you observe, the entire ray is being reversed or turned by, you can say, 180 degrees in this case. Reversed basically. And just check out the things. Okay. So this is how you can actually bend the light by 90 degrees or by 180 degrees and so on, depending upon our requirements. Where do we require them and what we require? We use these glass prisms in this manner. The third diagram also shows you the same thing. You can see the reflection is total internal reflection is made to happen in such a manner that this the image gets inverted. All right. These are the three diagrams which are sufficient for you to understand how we can change the path of light depending upon our requirement. Important thing is our requirement. What do we require? Accordingly, we can use this phenomena using prism. Okay, so this is something which you need to understand. Please make a note of it. Hopefully, you have understood this, and then I will tell you where exactly we apply this concept. So please make a note of it and let me know once you're done with it. Hopefully, things are getting pretty clear to everybody. The representations are made in such a manner that you should understand it by looking at it. The important thing, most of you say done, so let's move ahead then. Then where do we apply this concept? So obviously we would be applying this concept in prism binoculars. So for example, this is the view from the binocular. Now we all know why we need binoculars. Okay, we can see the distant objects basically, especially the ship. This is a view from a binocular. Now look at it. What happens in a binocular? You can see. So here is this is the eyepiece. This is the object. Right. We between this can have an arrangement. So we're looking at the ship, right? The image is being formed here, and then the rays coming from the image, you can see they are bent. to 90 degrees by this prism. You are able to observe it. Now, how is this prism doing it? Obviously, by the phenomena and the process which we have discussed, right? There is total internal reflection of light. You can see the rays being turned by 90 degrees. When it falls on another prism, again it's turned by 90 degrees, and again it's turned by 90 degrees, so that straight away these rays then enter your eyes. Whatever is happening on this side of this section of the prism binocular, same thing would happen here also, owing to symmetry. So then, in that case, friends, if you try to observe it, you can see what's been happening over here. So, totally reflecting prisms. We are making the use of this concept. This is something which we have seen in the first slide itself. What happens is the inverted image is being formed. Just give me a moment. When you observe the shift, basically, so what's happening? This is something which I was discussing. Say, for example, the shift is being observed, the rays come, image is being formed at this level. Further, because of this prisms which are being used in the binoculars, just change the path of the light rays. Ultimately, you can have a magnified image, basically, and then you are able to see the distant object clearly. So you can have a look at it. Yes. So whatever would be happening here, this side of the section, the same thing happens here. This is where you actually use the concept of prism binoculars, where you view the distant object. Please make a note of this. So here the concept which is being used with the help of these prisms is total internal reflection of light. So once you are done with it, please let me know. So, even this done. Most of you said that. Now, the same fundamental can be used in periscopes also. Alright. The same fundamental, you can use it in periscopes. Okay. What exactly we do in that case? So just give me a moment so that I can share a different slide. Yeah, okay. But here we are not using the concept of total internal reflection of light. Here we are using plane mirrors instead of prism. Then it would be because of reflection of light. Simple case of reflection. Let's understand how a periscope looks like. A picture of a periscope. And what a periscope does, basically, you use it to see objects which are not in the same level as that of observer. Like, you are in a submarine and you want to view what's happening on the surface of the sea. So you use periscopes for that. So obviously the images are to be transferred from the top to the bottom where your eye is placed. So either you can make use of prisms over there just to turn the light rays by 90 degrees, or you can use plane mirrors also. So plane mirrors won't be using the concept of total internal reflection of light. They will be simply reflecting the lights as per the concept of reflection of light. But when we talk about prisms, then prisms, you have to turn the light through 90 degrees, light rays to 90 degrees. You use the concept like total internal reflection. So please make a note of this and let me know so that we move ahead. I can show you the ray diagram, how images get transferred from top to bottom in case of a periscope. We can have a comparative study, alright, so far as periscope is concerned. Here you can use mirrors also, and here you can use prisms also, because ultimately the methodology which is being adopted over here is regarding how you change the path of light by 90 degrees. Okay, let's see. Let's move ahead then. Yeah, here you can see. Say for example, a person who is at this particular level and the apple is at the top, he wants to view the apple. Then what's going to happen? If you fix a plane mirror over here, the rays coming from apple will get reflected in the 90 degrees manner. Straight away here also you have another plane mirror placed in this fashion, which again reflects, turns the ray of light by 90 degrees. The observer is able to see the apple, which generally he was not able to see because it's not at his eye level. But still, because of the image formation and transferring in this manner, what's going to happen? The person will be able to see the apple, which is not at his level. The same thing I'm trying to tell you. With the help of mirrors, you are reflecting it by 90 degrees. Had you used prisms over here, all right, so the same thing was possible with the prism also. Now, what's the difference between using plane mirror and prism? In prism, we are more comfortable dealing with prism for the greater clarity, and at times, plane mirror will just plane mirror basically would give you the image of the same size. And now, if I want to change the magnification of the images, then in that case, prisms would be more uh, you know, useful as compared to plane mirrors. But the way plane mirrors are used over here, in case of the periscope, what I want to tell you is you can use the prisms also. Okay? So where we will be using the concept of total internal reflection of light to bend the ray of light by 90 degrees. So please make a note of this, and then once you're done with it, let me know that we talk further. As Soham is asking, periscope shows zoomed images. It all depends how you adjust focus. Soham. Plane mirrors will give you the image of same size, but had it been prisms, because of the it's giving you total internal reflection of light. Basically, it would be making things easier. You may get a magnified image there, depending upon how you place the prisms or the size of the prism. This is something which we want to study details, the later stages. Okay, how we actually change the sizes of the image as per our requirements. Hopefully, this slide is dealt with from your side. So just let me know so that we move ahead then. So, yes, here you can see how it works. Now, wouldn't you? They're making all these arrangements. You can see the object is at the top, and obviously the image is formed in the eyes of the observer who is located at the bottom. Here we are mostly discussing mirrors, but what I mean to say is the same thing can be replaced with the help of prisms also. Please make a note of this before I show you the next slide, friends. Hopefully done. Then let's move ahead and this is done. And have a look at it. It's based on multiple reflections. That's what we have seen. The optical device which will enable the observer to view surrounding objects from the lower level. And where do we use them? Basically, we use them in submarines and the trenches to observe the enemy movements without being seen. That's the important thing. Periscope for us. Please take a look at this and let me know what you think. Most of you say yes. Friends, today what we have done is we have discussed the total internal reflection of